Hello students, welcome to Gnana Deeksha, concept-based digital learning. My name is Rajitha Deshineni, lecturer in chemistry from Telangana Social Welfare Residential Degree College for Women, Budvel. Before entering into the topic, I would like to discuss some common things in our daily life. Many of us habituated to take a cup of coffee in the morning because it can activate our central nervous system due to the presence of caffeine in the coffee. Do you know what is caffeine and comes under which category in chemistry? And we all are very familiar with the penicillin antibiotic. Why penicillin having that much of biological activity? And also, if we take our human beings, every human being showing a unique features because their genes, nothing but DNA. DNA basically constructed by nucleotides and nucleosides. Did you ever listen about nucleotides and nucleosides? Dear students, all these discussed compounds, caffeine, penicillin antibiotic, nucleotides and nucleosides are basically heterocyclic compounds. Even hydroxychloroquine drug, which became familiar due to this COVID-19, also having heterocyclic moiety. Not only these compounds, so many pharmaceutical drugs, pigments like chlorophyll, hemoglobin, vitamins like B12 are having heterocyclic compounds are their core moiety. So, due to the importance of heterocyclic compound, we should aware of these compounds. So, today in this session, I am going to dealing with heterocyclic compounds. By the end of this session, you will be able to know classification of organic compounds, what are the heterocyclic compounds, nomenclature of heterocyclic compounds, and we are going to discuss about a basic heterocyclic compound, pyrrole, introduction and aromaticity of pyrrole, preparation methods of pyrrole, acidity and basicity of pyrrole, finally industrial applications of pyrrole. So, let's discuss how heterocyclic compounds derived from organic compounds. We know that organic compounds are compounds which are formed by the combination of carbon and hydrogen atoms. We also know that carbon is having catenation property. Due to this catenation, carbon is forming large group of organic compounds. So, to study or to simplify the study of organic compounds, these are broadly classified into two categories. Those are open chain compounds and cyclic compounds. In open chain compounds, the carbon and carbon bonded to each other to form a linear or open chain type of structure. So, based on their structure, those are calling as open chain compounds. Example, N-butane, N-propane, N-pentane, etc. If we see the cyclic compounds, in cyclic compounds, carbon and carbon bonded to each other to form a closed ring, cyclic type structure. So, based on structure, those are calling as cyclic compounds. And again, these are classified into two categories. One is homocyclic compound and another one is heterocyclic compound. So, let's see what are the homocyclic compounds. Here, homo nothing but same. Means in homocyclic compounds, those are containing only carbon atom, means having same type of atoms. So, the cyclic compounds which are having only carbon atoms, those are called as homocyclic compounds. Example, cyclohexane, cyclopentane, etc. Next, heterocyclic compounds. Here, hetero nothing but different, means other than carbon atom may present in heterocyclic compounds. Generally, nitrogen, oxygen, sulfur, etc. are called as hetero atoms. So, finally, the definition of the heterocyclic compounds is the organic cyclic compounds which are having hetero atoms like nitrogen, oxygen, sulfur, etc. along with carbon atoms, those are called as heterocyclic compounds. Look at the picture. These are the examples of heterocyclic compounds. Here, basically, these are the cyclic compounds and having hetero atom, oxygen and nitrogen. So, we can say that these are the heterocyclic compounds. Dear students, we discussed that carbon is forming large group of compounds due to the catenation property. Again, in that around 65% of organic compounds are heterocyclic compounds only. So, if we want to read about a particular heterocyclic compound, how can we identify the compound? For example, if we take our classroom and wants to introduce a particular student, then we start the introducing her by name. Like this, to read about a particular heterocyclic compound, we need the name of the compound. So, let's see the nomenclature of heterocyclic compounds. Generally, these are having two types of names. One is common name and another one is IUPAC name. Generally, common name is given by nature or occurrence or based on any physical property of the compound. And IUPAC name is, it is a method of naming as recommended by IUPAC. Here, the heterocyclic compounds IUPAC naming system proposed by Hansch-Widman. So, we are also calling this system as Hansch-Widman system. In this system, we can give name of the compound by adding prefix and suffix of the compound. Here, prefix nothing but first word of the name and suffix nothing but last word of the name. So, let's see how can we give prefix. Whenever we want to give prefix, first we have to see type of heteroatom, means whether it is having nitrogen or oxygen or sulfur, etc. Look at the picture. If in the given compound, if a heteroatom is nitrogen, then prefix is aza. Like if in the given compound heteroatom is oxygen, then prefix is oxa. Like sulfur, prefix is thia, and selenium, then prefix is selena. Like this, by using reference prefix, first we have to give the prefix. Next, we have to give suffix. In order to give suffix, we have to see ring size and nature of the ring. Here, ring size means whether it is having 5-membered or 6-membered ring. And nature of the ring means is the ring is unsaturated or saturated compound, and whether it is with nitrogen or without nitrogen. So, now look at the table carefully. If the given compound is 5-membered, unsaturated with nitrogen atom, see the table. Here the reference suffix is ol. Even for 5-membered unsaturated without nitrogen atom, also suffix is ol. But for some compounds with nitrogen atom and without nitrogen atom, the suffix may be different. Next, if the given compound is saturated with nitrogen atom, then the suffix is ine. And if the given compound is without a nitrogen atom, then the suffix is ane. Like this, by using reference, prefix and suffix, we have to give prefix and suffix, and finally we have to add the prefix and suffix of the compound. Let's see some example. Look at the picture. Here, this is the 5-membered ring. According to process, first we have to give prefix. So, here heteroatom is oxygen. So, prefix is oxa. Next, give suffix. This is a unsaturated compound and 5-membered without nitrogen atom. So, see the table carefully. Here the given suffix is ol. So, finally we have to add prefix and suffix oxa plus ol. While adding oxa and means prefix and suffix, we have to remove the last letter of prefix. Here, last letter is A. So, we have to remove the A. Finally, we get the name is oxole. Next, let's see one more example. Here also, we have to follow same procedure. And I hope you also will try to give name along with me while I am explaining. So, first we have to give prefix. So, here heteroatom is nitrogen, so the prefix is aza, and suffix is, here this is the 6-membered ring unsaturated compound with nitrogen. So, see the table. Here given reference suffix is ine. So, finally we have to add the prefix and suffix, that is aza and in, we get the name azine. So, like this we have to give naming of the heterocyclic compound. Next, let's see one of the most simple and basic 5-membered heterocyclic compound, that is pyrrole. See the structure. Here this is a pyrrole is a 5-membered nitrogen containing heterocyclic and aromatic compound. Here if we see the structure, here it is having 4 carbon atoms and 1 nitrogen atom and 5 hydrogen atoms. So the molecular formula of the pyrrole is C4H5N and the IUPAC name is azole, common name is pyrrole. Let's see the introduction of pyrrole. Pyrrole was first detected by a German analytical chemist F.F. Runge as a constituent of coal tar. Later it was isolated from the bone oil, which is called as pyrrolysate. And this pyrrole name was derived from Greek language. In Greek, pyros means reddish. Here the relation between this red color and pyrrole is it's giving red color on moistened with hydrochloric acid. So based on this reaction, it gets common name as pyrrole. And it is one of the important heterocyclic compound among other heterocyclics like thiophene, furan, pyridine, because it occurs in various natural products like chlorophyll. Here we know that chlorophyll is a green pigment and reason for the photosynthesis in plants is chlorophyll only. See the structure. It is having a central metal ion Mg+2 and surrounded by porphyrin ring. This porphyrin ring is polymer of pyrrole. And one more natural product is hemoglobin. It is an oxygen carrier and it is the red pigment present in the human blood. This is also having, see the structure, this is also having porphyrin ring which is constructed by pyrrole. And one more example is bile juice, here which is secreted by liver and having pigments like bilirubin and biliverdin. These pigments also having open chain pyrrole molecules. You can see the picture here. These are the polymers of open chain pyrrole molecules. And not only these, so many alkaloids like nicotine and vitamins like B12 having pyrrole as core moiety. So let's discuss some more things about pyrrole. I said that pyrrole is 5-membered heterocyclic and aromatic compound. So why it is an aromatic? Let's check. First of all, any organic compound to be aromatic, it should obey some conditions. Those are, it should have cyclic and planar structure and it should have delocalized pi electron cloud and should obey Huckel's rule. Here Huckel's rule nothing but having pi electrons equals to 4n+2 value, 4n+2 pi electrons. So let's check whether the pyrrole is following these conditions or not. See the structure. Pyrrole is in cyclic and the carbon and the nitrogens are sp2 hybridized. So this is having planar structure. So first point is it's obeying, it is having cyclic and planar structure and it is having 6 pi electrons. 4 pi electrons are from 2 double bonded carbons and a pair of non-bonding electrons from heteroatom. And these 6 pi electrons in conjugation means it is having delocalized pi electron cloud. And it should obey Huckel's rule. According to Huckel's rule, it should have pi electrons equals to 4n+2 value. If n equal to 1, then 4 into 1 plus 2 equals to 6. So therefore, Huckel's rule is satisfied. Since it is following all aromatic conditions, the pyrrole is an aromatic compound. We are saying that pyrrole is core moiety in many natural products. So, due to the importance of pyrrole, sometimes we need to prepare this in laboratory. So, let's see the various preparation methods of pyrrole. First one is preparation of pyrrole from furan. Furan and reaction with ammonia will get pyrrole. Here in this reaction, we are preparing pyrrole from another heterocyclic compound furan. See the schematic representation of the reaction. First one is furan and reaction with ammonia in the presence of alumina at 480 degrees centigrade will give pyrrole and the byproduct is water. Here we are not using any organic solvent and the byproduct is eco-friendly water. So this is the green synthesis, and carrying out this reaction in laboratory is so easy. So it is a commercial preparation method of pyrrole, and preparation of pyrrole from distillation of succinamide. We can able to prepare pyrrole from succinamide also. In this, first succinamide converted into enol form. In this enol form, it is reduced by the zinc dust and form pyrrole. And one more method is preparation of pyrrole from acetylene and ammonia. Pyrrole gets prepared by passing the mixture of acetylene and ammonia through red hot tube. See the reaction. Here we have taken 2 moles of acetylene and 1 mole of ammonia. While passing the mixture through red hot tube, first it gets fusion. By cyclization of these molecules will give simple pyrrole. Dear students, till now we discussed about a simple preparation of simple pyrrole nucleus. But in the organic reaction mechanism and in medicinal chemistry, there is lot of importance for substituted pyrroles also. So for the synthesis of substituted pyrrole, we have few new reactions. And these are very important while facing laboratory interviews as well as while facing competitive exams. So let's see one by one. Preparation of substituted pyrrole from NOR synthesis. In this synthesis, 1,4 dicarbonyl compound treated with ammonia or primary amine to form substituted pyrrole. This is a condensation reaction. Means by eliminating simple molecules like water, ammonia will get addition product. Look at the picture. Here the first molecule is 1,4 diketone. On heating, it cyclizes with ammonia and will give 2,5 disubstituted pyrrole molecule. This is the general schematic representation. We can take various substituents in the place of R groups. Let's see one example. If we take 2 methyl groups in the place of R groups, then that is the hexane 2,5 dione. First, this is converted into enol form. In this enol form, it is cyclizes with ammonia and will form 2,5 dimethyl pyrrole. This is the precursor in many organic reactions. For example, preparation of artificial porphyrin ring. In this reaction, this 2,5 dimethyl pyrrole is precursor. Next one is NOR synthesis. This is also a condensation reaction. It involves the condensation of alpha amino beta ketone and with another ketone having active methylene group. Here active methylene means having CH2 group in between electron withdrawing groups such as ethyl ester. See the reaction here. First one is the alpha amino ketone and the second one is active methylene group having ketone, and condensation will get substituted pyrrole. This is also very important precursor in various drug synthesis. This is the next one is Hansch pyrrole synthesis. This is the chemical reaction of beta keto ester with ammonia and one more alpha halo ketone. This is also a condensation process, and addition of these 3 compounds will get substituted pyrrole. These are the various preparation methods of pyrrole. I hope you understood the preparation methods of pyrrole. Dear students, now I want to ask you a question. Is pyrrole acid or base? Let me explain. To answer this question, first we have to know what is base and what is acid. According to Lewis, base is an electron pair donor and acid is an electron pair acceptor. See here, pyrrole is having a non-bonding electron pair on nitrogen atom. So by donating this, it can act as a base. But the non-bonded electron pair present on the nitrogen atom involving in 4n+2 pi electron cloud means it's involving in resonance. Look at the screen. Here you can see the delocalization of electron pair. Due to this delocalization, the electron pair present on the nitrogen atom not at all available to donate at all the times. So pyrrole can act as a weak base. Next, let's see the acidity of pyrrole. Here, according to Bronsted, an acid is a proton donor. Here, pyrrole is having a proton and more electronegative atom, nitrogen. So, by donating this proton, it can act as a acid. Here, pyrrole and reaction with a strong alkali will converted into anion, which is called as pyryl anion. See the reaction. First one is pyrrole. By losing proton, it is converted into conjugated base, that is anion, that is called as pyryl anion. And this pyryl anion is more stable than pyrrole because resonance effect. Look at the reaction. This is the pyrrole. After losing proton, it becomes conjugate base, and that means pyryl anion. This pyryl anion is more stable than pyrrole because resonance effect. So let's see the resonance of pyrrole. Here you can see the resonance of pyrrole. The canonical structures of pyrrole is having charge separation. Due to this charge separation, it's getting less stability. And look at the screen. Next, these are the resonance structures or canonical structures of pyryl anion. Unlike pyrrole, these are not having any charge separation. So, pyryl anion canonical structures are more stable. So, to get the more stable pyryl anion, pyrrole can lose proton and will act as a weak acid. So, as our discussion, pyrrole is acting as a base as well as acid. So, pyrrole is having amphoteric nature. Next, let's see some industrial applications of pyrrole. Pyrrole is using as corrosion inhibitor, means it coated on the metal surfaces to control the rusting of metals, and this is also using as the precursor in the preparation of various drugs. Example, preparation of artificial porphyrin ring method, and we also using as a pyrrole as solvent in many reactions, and pyrrole is using as catalyst in polymerization reactions. These are the industrial applications of pyrrole. Now let's summarize the today's whole session. In this session, we have learnt about, first of all, the classification of organic compounds. That is, these are classified into open chain compounds and cyclic compounds. Again, these cyclic compounds classified into homocyclic and heterocyclic. We discussed about these heterocyclic compounds only. So, the definition of heterocyclic compounds is the organic cyclic compounds which are having heteroatoms like nitrogen, oxygen, sulfur along with carbon atoms. Those are calling as heterocyclic compounds. And we also seen that importance of heterocyclic compounds as pharmaceutical drugs like penicillin, hydroxychloroquine, and some other pharmaceutical drugs are there. And we have seen in our daily life compounds like chlorophyll, hemoglobin, and vitamins like B12. We have discussed about that. And also we have seen about nomenclature of heterocyclic compounds. Here heterocyclic compounds are having two names. One is common name and another one is IUPAC name. That IUPAC naming system proposed by Hans Widman, which is very important naming system in heterocyclic compounds. And we have seen one of the most important and basic heterocyclic compound among others, that is pyrrole. Pyrrole is because pyrrole is having lot of biological importance in a natural, it's occurring as natural products as well as some artificial drugs. And so that we have seen about pyrrole introduction and aromaticity. And we have seen the various preparation methods of simple pyrrole by preparation of pyrrole from furan and from distillation of succinamide and from acetylene. And also we have seen the substituted pyrrole synthesis by few named reactions which are very important. Those are Paul-Nash synthesis and Nash synthesis and Hansch synthesis. All these syntheses are condensation reactions only, and these are very important named reactions while facing laboratory interviews as well as competitive exams. and we have seen about acidic and basic property of pyrrole, nothing but amphoteric nature of pyrrole because it's having a non-bonding pair on nitrogen atom to act as a base, and it's having a proton on more electronegative atom to act as a acid. So finally pyrrole is having amphoteric nature. And we have discussed about industrial applications of pyrrole. Those are as pyrrole is using as inhibitor, corrosion inhibitor, and solvent and catalyst in many polymerization reactions, as well as we are using pyrrole as precursor in various drug synthesis. We know that porphyrin ring, artificial preparation of porphyrin ring is done by pyrrole only. So these are the we discussed in our whole session, and now I would like to conclude my session with an assignment. Dear students, while I am searching the chemical composition of some daily life products like avocado, aloe vera gel and rose petals, I was shocked. All of those are having heterocyclic as their chemical composition. So, dear students, try to find out the heterocyclics around you. Thank you.